Good morning. This is Dr. Anjaneya Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, I am going to discussing about determination of EDTA, determination of hardness of water by using EDTA method. Actually, this method is also known as complexometric method. Before going to the estimation of hardness by using EDTA method, here we have to know that what is a complex. Usually, complex is we can define as matter plus ligand gives rise to complex. Here we know that. So what is the ligand? What is the matter? Matter is always trying to release electrons. Electron release group. Ligand is always trying to donate electrons to the matter. So once matter releases electrons, what will happen? Matter convert into matter ion. This is electron deficient species. Matter ion act as a electron deficient species. Here, when you are adding ligand to the matter, ligand is the electron efficient species. Here, ligand act as a electron efficient species. Electron efficient species. That's why ligand can donate electrons to the metal, forms coordinate covalent bond. During the donation of electrons by the ligand to the metal, forms metal ligand complex. Metal ligand complex. So that is the complex. Here we are going to estimate hardness of water by using EDTA method. So we know that first of all, what is the hardness of water and what is the reasons for hardness of water. Salts of calcium and magnesium causes hardness to the water. That is chlorides, sulfides, carbonates of calcium and magnesium. Calcium and magnesium causes hardness to the water. So here we are going to estimate hardness. We are going to estimate hardness by using EDTA. EDTA. It is nothing but cationic estimation. Hardness of water which is caused by cations. Here, what type of cations present in hard water? That is calcium and magnesium. These are the two cations present in hard water. Here we are going to estimate how much amount of calcium and how much amounts of magnesium present in hard water. It can be estimated by using EDTA. So here, what is the EDTA? What is EDTA? EDTA stands for ethylene diamine tetraacetic acid. E stands for ethylene, D stands for diamine, T stands for tetra, A stands for acetic acid. Ethylene diamine tetraacetic acid. Here, EDTA act as a ligand. EDTA act as a ligand. By using EDTA, we can catch the whatever cations present in the hard water. So here cations there are two types of cations present in hard water, that is calcium and magnesium. So here complex will be formed during transfer of electron from EDTA to metals. EDTA to metals forms coordinate covalent bond. Okay, next coming to the principle. Principle of EDTA method. What is the main principle of EDTA method? Here, method. Here, coming to the principle of EDTA method. When hard water, usually hard water, some amount of hard water is taken into the some beaker. To that add EBT. So what is the EBT here? Heliochrome black tea. EBT. Here EBT act as a both indicator as well as ligand. Indicator as well as ligand. Here, when metals, that is a cations present in hard water, that is calcium and magnesium, react with EBT in presence of pH 8 to 10. Calcium EBT complex is formed. Calcium EBT complex is formed. Here we have to add buffer to the reaction. So what is the use of buffer? Why we should add buffer to the reaction? To maintain pH range 8 to 10. So for that purpose we have to add ammonium hydroxide plus ammonium chloride buffer. That is a basic buffer. Here this buffer acts as a basic buffer. So in this reaction we have to maintain pH around 8 to 10. That's why we have to add buffer solution to the reaction. So calcium EBT complex has been formed. The color of the complex is violet color. But this is the very unstable complex. Unstable complex. Why we should call it is unstable complex? That's why we had to study the denticity of ligand, denticity of EBT. So here what is the denticity? What is denticity? What is denticity? Denticity is nothing but tendency to donate electrons. Tendency to donate electrons. Tendency to donate electrons is known as denticity of that ligand. How we can find the denticity? How we can find out the denticity? Simply by seeing the structure of a ligand, we can understand what is the denticity of that particular ligand. Let us see the structure of EDT and EBT and calculate denticity. Look at here. Coming to the EDTA structure. Ethylene, diamine, 1, 2, 3, 4. Tetraacetic acid. It is a EDTA. So let us calculate donor centers. How many donor centers present in the EDTA structure? If you find out the donor centers, Then you can understand denticity. What is a denticity? Denticity tells about number of donor centers present in a structure. Let us calculate donor centers. How many donor centers? 1, 2, 3, 4, 5, 6. Here, 4 hydroxyl group and 2 nitrogen lone pairs act as a donor centers in EDTA structure. Totally 4 COH groups, 4 COH groups and 2 nitrogen. Totally 6 donor centers. 6 donor centers present in EDTA structure. That's why EDTA act as a hexadentate. Hexadentate. That's why EDTA act as a hexadentate ligand. And if you see the structure of EBT, this is the EBT structure. This is the EBT structure. In EBT structure, let us calculate the donor centers. 1, 2, 3, 4. 4 donor centers present in the EBT structure. That's why EBT act as a tetradentate. Now we can understand EDTA is a strong ligand than EBT. How we can say that EDTA is a strong ligand than EBT? Depends on donor centers. Here 6 donor centers present in EDTA structure. Already we have counted, we have calculated. And 4 donor centers present in EBT. Then we can say that EDTA act as a strong ligand than EBT. That's why metal forms complex with EBT. That is a weak complex. That is the weak complex. So this is the metal react with EBT. This is the weak complex. Then EDTA. So next going to the EDTA to this complex. What will happen? Let us see. So calcium magnesium EBT complex, which is present in red color, to this add EDTA at pH range 8 to 10. That is a basic buffer. The basic pH. To maintain pH 8 to 10, we have to add ammonium hydroxide buffer. So EDTA can replace the EBT present in the complex. EDTA can replace the EBT present in the complex. This is a stable complex, stable and strong complex. Why? Because here EDTA act as a hexadentate ligand, EBT act as a tetradentate ligand. Depends on number of donor centers. EDTA can replace the EBT present in the complex and forms stable complex. Stable complex. It is a colorless complex. Colorless complex. That is a principle of complexometric method. That is the principle of complexometric method. Okay. Next, going to the principle. Next, this is a complexation structure. So EDTA forms a complex with matter through a 6 coordinate covalent bond. 1, 2, 3, 4, 5, 6. 6 coordinated covalent bonds. Why? Because here EDTA acts as a hexadentate ligand. EDTA has 6 donor centers. That's why it has to transfer electrons from 6 donor centers to metal, forms 6 coordinate covalent bonds. Okay. Next, going to the procedure. How we can estimate the hardness of water by using EDTA. EDTA. So before going to that, it is nothing but titration. Titration method. Complexometry is nothing but titration method. Here, before going to the titration, first we have to know that what is a titration. Titration is nothing but determination of concentration of unknown substance by using known concentration of substance. Determination of concentration of unknown substance by using substance with the known concentration. That is a titration. So here we are going to determine hardness of water by titration method. Here, before going to the titration, here we have to know what is a primary standard and what is a secondary standard. Why? Because in our determination of hardness of water, first step is standardization of EDTA. So what is the standardization of EDTA? That's why we had to discuss. There are two types of standards in our chemistry. That is primary standards and secondary standard. Secondary standard. So what is a primary standard and what is a secondary standard? Coming to the primary standard, compounds with the fixed concentrations, that is known as primary standard. Next, what is the secondary standard? Concentration of the compounds will be changed time to time or minute to minute. That is known as secondary standard. Here, our EDTA belongs to type of secondary standard. That's why before going to the titration method, first we have to standardize EDTA. First we have to standardize EDTA. Let us see the standardization of EDTA. Let us see the standardization of EDTA. So here EDTA is, I'm going to take in a burette, and it is standardized by some primary standards like magnesium surface solution, etc. So I'm going to take some magnesium sulfate solution with a conical flask. To this add few ml of EDTA indicator and buffer solution and 2-3 drops of buffer solution, that is NH4OH and NH4Cl. NH4OH and NH4Cl, we have to add a conical flask. So here color of the solution present in conical flask is violet. Okay, here when you are adding EBT plus buffer to the MgSO4 solution, there forms magnesium EBT complex. EBT complex has been formed. And next, it is going to the titrated with EDTA until violet color is converted into colorless. That is the end point of the titration. Violet color complex is converted into colorless complex. That is the end point of the titration. Here, when you are adding EDTA to the magnesium EBT complex, EDTA can replace the magnesium EBT complex. When you are adding EDTA through burette, EDTA can replace the EBT present in the complex. Magnesium EDTA complex has been formed. So this is a strong ligand when comparing magnesium EBT complex. Already we discussed on the basis of denticity, number of donor centers present in the structure, EDTA can replace the EBT present in the complex. So that is the end point of the titration. By using these values, we can estimate how much amount of hardness present in the water. We can estimate. That is the first step, is standardization of EDTA. Coming to the calculations, volume of standard hard water, let us consider as 20 ml. Next, molality of standard hard water, that is a concentration of the MgSO4 solution. Here we are using MgSO4 solution as a hard water to standardize EDTA. So that concentration of MgSO4 solution is 0.01. Next, volume of EDTA unknown, that is the end point of the titration. V2, how much amount of EDTA unknown, that is, let us consider XML. Next, M2, strength of the EDTA solution, we have to find out. So according to the volumetric law, V1 M1 is equal to V2 M2. M2 is equal to V1 M1 by V2. So strength of EDTA is equal to 20 into 0.01 by XML. By using this formula, we can find out the M2 value, that is the standardization of EDTA concentration. After completion of standardization of EDTA, next going to estimate hardness of water. Okay, here volume of hard water. Here I am going to take hard water in place of MgSO4 in a conical flask, that is V3. How much? 20 ml. So 20 ml of hard water we have taken into the conical flask. Again to that add few amount of EBT indicator plus buffer solution, and it is titrated with EDTA until color change. Initially color of the complex is violet. When you are adding EDTA at a certain point, that color is converted into colorless. Your magnesium EDTA complex is formed. Here, volume of hard water sample taken into conical flask, that is V3, 20 ml, and molality of hard water sample is M3. We have to calculate. And volume of EDTA consumed is V4. Strength of EDTA is M4. Already we know that strength of EDTA through a standardization step, we have determined strength of EDTA. That's why I am taking M4 is equal to M2. So according to our metigram, V3 M3 is equal to M4 V4. Then M3 is equal to V4 M4 by V3. Then YML into M2 by 20. So by using this formula, we can find out the estimation of hard water. How to estimate amount of hardness present in a water sample through a complexiometric method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.